Hello everyone. In this video, I will explain the most repeated model in JMain in the topic of matrices. That particularly repeated model is how to find out the determinant of adjoint of a matrix and what is the inverse of a matrix and what are the simple properties of adjoint of a matrix. Adjoint of determinant of adjoint of A, like when you take one adjoint, two adjoint, three adjoint, etc. These models frequently coming in JEE main exam. There are not less than 30 questions asked in previous JEE main based on determinant of adjoint of a matrix or determinant of adjoint of a matrix. So I'll explain the concept in detailed way, followed by I will solve some previous JEE main questions. Here I have taken a 2 by 2 matrix. Based on this, after that I'll write a 3 by 3 matrix. See, how do we find out that adjoint of a matrix? So before we find adjoint of a matrix, we must know what is cofactor. Well, so here I am writing that cofactor of A11 means the very first element in the given matrix. We will denote it by A11. So this is equal to -1 whole to the power of 1 plus 1. You write these numbers, okay? And you see, remove the first row and first column. Means remove the rows and columns containing this element. Remove the rows and columns containing this element. So when you are here, A11 is in the first row. So remove the first row. This is the row 1. And A11 is in the first column. So this is the first column. So by removing first row and first column, there is only one element left. So that you have to write A22. This is only one element, right? So which means that here determinant of this A22 is nothing but A22, right? So this is nothing but simply A2. Now what is cofactor of A12? Next element. So we'll denote it by A12. So we will write this is -1 power 1 plus 2 into. Now remove the first row, right? And second column. So remove first row and second column. Then A21 is left, right? So here, this is actually determinant. Here we write determinant. It is not at all modulus. It is a determinant. So determinant of a single element of a matrix is nothing but that element itself. Okay. So here again determinant of here A21. Here -1 whole power you get odd number 3. So it becomes -1. You will get A21 minus of. This is equal to minus of. So what is cofactor of next element A21? This is equal to A21 equal to, we write -1 whole to the power of 2 plus 1. Now remove second row and this is first column. Remove second row. This is row 2 and this is in column 1. Right. So remove this, remove second row and first column. So A12 is left. This is A12. So this is equal to, you will get minus A12. Now what is the cofactor of last element of given matrix A22? So this is equal to, we will denote it by A22. This is equal to minus 1 whole to the power of 2 plus 2. Determinant of, now remove the second row and second column. Second row, second column, after removing, there is only one element left, that is A11. So this becomes A1. These are the cofactors. Now, how do we define adjoint of a matrix? So now here, adjoint of A. Here, adjoint of A. Of A. Above matrix, this is 2 by 2 matrix. Adjoint of A 2 by 2 matrix equal to, you write the cofactors as it is A11, A12, A21, and A22. These are the cofactors. After that, you have to take the transpose. So this is equal to, transpose means write the row elements in column. So here A11, A12, and this is A21, A22. Well, so which means that first row elements cofactors written as first column. Second row elements cofactors written as second column. Means row elements of cofactors written in column wise. So now this is equal to, we'll write that adjoint. You see, the first one is A22. Next, what are the A11? So A11 is A22 and A12 is minus A2. Write the cofactor elements of first row in column. Okay. Next here minus A12, here A11. So this is the process of finding adjoint of a 2 by 2 matrix. This is very, very important. So now, suppose if I give A equal to A, B, C, D, A, B, C, D. Well, then what is the adjoint of this matrix? Adjoint of A equal to, okay. So here, my meaning of this means adjoint. So I'm writing, we'll denote like this only. So adjoint of A. So this is equal to, you see, here you observe, these elements are interchanged. Here, these elements are interchanged. You see, here, these two are interchanged. So here, interchange these two. So this is nothing but D, here A. And after that, you see, these elements appeared as it is, but with the opposite sign. So here, you will have minus B, and here you will have minus C. So this is adjoint of 2 by 2 matrix. So for example, one example I am providing, A equal to, suppose if you take 1, 2, minus 3, 4. Now what is adjoint of A? So here adjoint of A is, you can write either capital A or small a. So here adjoint of A equal to, you see, interchange these two. So interchanging these two means you will have 4, 1. And now next elements you keep as it is, but you write in with opposite sign. So here you have to write -2 and here you have to write 3. If you feel that I'm teaching slow, then you can increase the speed in YouTube channel. You can listen, you can watch this channel with a speed of 1.25, 1.5. It depends upon candidate caliber, right? So here, now I have explained that adjoint of a matrix for 2, right? Now, what is the adjoint for a 3 by 3 matrix? So let a equal to I will take a 3 by 3 matrix, a 3 by 3, like this. Okay. So according to the definition, I have explained here that cofactor of Aij, cofactor of Aij equal to -1 whole to the power of I plus j, right, into determinant of matrix of a matrix, right? Determinant of a matrix obtained by removing ith row and jth column right, in A, in the matrix A. So this is nothing but A11. So cofactor of Aij is nothing but this is capital Aij, right? So for example, I'll explain in detailed way. So here is, for example, the full form of this matrix is A11, A12, A13, A21, A22, A23, A31, A32, A33. So this is the 3 by 3 matrix. Now, how do we find out a cofactor of, let us say, what is cofactor of A12? So A12. Now I need not to write that cofactor of A12. It indicates that cofactor of A12. So -1 whole to the power of 1 plus 2, determinant of, right? Now remove this row, first row. This is first row. Remove first row and second column. So you write the remaining elements A11, A13, A31, and A33. Well, okay. So therefore, this is nothing but cofactor of A1. Similarly, you can find cofactors of all 9 elements. Now, what is adjoint of this matrix? Adjoint of A of 3 by 3 matrix. Well, this is equal to what I have tell you that you write the cofactors of first row elements in column. So cofactors of first row elements in column means A11 here, A12 here, A13. Next, A21 here, A22, A23. Now, third row elements, cofactors, we write in column wise. So here, A31, A32, and A33. So this is the adjoint of a 3 by 3 matrix. So without basics of adjoint of a matrix, I cannot go further. So now, what is A into adjoint of A? That will play a vital role in finding determinant of adjoint of A. So here, now I'm explaining that what is A into adjoint of A, right? So here, I'll explain by taking a 2 by 2 matrix. Let A equal to A, B, C, D. I'm just taking A equal to A, B, C. So this video, I assume that you know how to find out a determinant of a matrix. Right. Then what is adjoint of A? What is adjoint of A? So adjoint of A equal to, you see, interchange these two, nothing but D, A, and keep negative sign for the remaining elements, like this. Now we will multiply that A and adjoint of A. We'll multiply A and adjoint of A. So what is A into adjoint of A? This is very, very important. If you understand this concept, you can solve the questions very easily. So now what is A into adjoint of A? Which means that we have to multiply these two matrices into here D minus B. This is adjoint of A minus C, A. This is equal to C. AD minus BC. Here AD minus BC. Minus AB plus AB, 0. CD minus CD, 0. Again, you will get here AD minus BC. So this is further, I can take that AD minus BC common into, this is 1, 0, 0, 1, which means it's an identity matrix, isn't it? Right? So this is equal to, this is nothing but determinant of A. So therefore, that A into I. So therefore, so what is A into adjoint of A? What is A into adjoint of A? A into adjoint of A equal to that A into I is a very, very important concept. This one. Well, so now we can extend this concept up to any order of a matrix. This is not only true for 2 by 2, this is true for 3 by 3, 4 by 4, for any order. So that I will write. Okay. So therefore, we can write that A n by n, or I'll write A 3 by 3, because in our exam, we will have maximum third order. So A 3 by 3 into adjoint of A 3 by 3. It is true not only for 3 by 3. It is true for any order. So determinant of A 3 by 3 into I. If you can remember this formula, it is very nice. And this also equivalent to, you can write that adjoint of A into A. Adjoint of A into A. So now I'll derive a few things based on this concept. A into adjoint of A equal to that A into I. So now, here you see, if A is invertible, or I can say if that A not equal to 0, then A inverse exists. Well, okay. So I assume that you know how to find out, or when does inverse of A exist. This video is particularly about determinant of adjoint. So now you see A inverse exists. Now A into adjoint of A equal to det A into I. This implies I want to find out A inverse. So multiply left side with A inverse. A inverse into A into adjoint of A. Okay. Matrix multiplication is associated. And here that A into A inverse into I. This is known as pre-multiply. Okay. So this implies this A inverse into A is nothing but an identity matrix. It is simply like you can think as a 1 in real number system. So 1 into x equal to x. So here I into adjoint of A is adjoint of A. So therefore adjoint of A by I'm bringing this det A this side equal to this is A inverse. So this is also very, very important with respect to JE main. So how to find out A inverse equal to, it is adjoint of A by det A, adjoint of A by det A. So now we'll come to the actual thing. Of course, these are also very important. Now, how do we find out determinant of adjoint of A? Here you see. Determinant of adjoint of A 2 by 2 equal to, or I can say, I can write n by n also equal to, this is determinant of A power n minus 1. Of course, here that A not equal to 0. And it is 0 if that A equal to 0. But in any case, only while proving this result, we need these conditions, but it is always true. So here we have a order n by n. Here the power n minus 1 means 1 less than the order of given matrix. So adjoint of determinant of adjoint of A equal to det A power n minus 1. So I'll prove for 2 by 2. After that, you can extend up to any order. Why I am proving for 2 by 2? So that everybody can understand. So here you see that A equal to A into adjoint of A equal to, we have that det A into I. Okay. Assume this is 2 by 2. This implies now taking both sides determinant. So det A into adjoint of A. This is 2 by 2 matrix. Now I am not repeating. I am not writing that order. Equal to determinant of det A into I 2 by 2. According to the matrix, we'll take this order. Well, so this implies this is det A into determinant of adjoint of A. I assume that you know the properties of determinants. So this is equal to, here, this is det A whole square into determinant of I. Okay, so here I can write a few things. that determinant of some k into a n by n, we can write as k to the power of n into det a. And determinant of AB equal to whatever I am using concepts here that I am writing. Det A into det. Well, now you see this implies okay, this implies here you see you can cancel one det A, right? So this implies adjoint of determinant of adjoint of A equal to det A if det A not equal to 0. So here this is 2 by 2. So that's why I have taken here this is power 1. So if we take A 3 by 3, now you see here if you take A 3 by 3, I am writing here determinant of A 3 by 3 So if we take 3 by 3 matrix, then also proof is similar to this only. If I take determinant of A 3 by 3 adjoint of A equal to determinant of det A into I. You must remember that A into adjoint of A equal to det A into I. So this implies left side one I can write det A, okay, and this is determinant of adjoint of A. Whereas RHS, if you take this as K and I is 3 by 3 matrix, so you can write KQ. So det A whole Q into det I. Now you see, one det A will be cancelled provided if det A is not equal to 0. So determinant of adjoint of A, after cancelling one det A, you will get this is det A whole square. If det A not equal to 0. So if A is n by n matrix, then determinant of adjoint of A equal to det A power n minus 1. This is also very, very important, this thing. Which comes very frequently in an exam. Later on, now, see, when det A equal to 0, it becomes 0. Obviously, you can prove by taking an example, or otherwise, we must go little deep. So, right now, that proof is not at all necessary. My aim is just to inculcate the main core property of adjoint. So, we know that we got determinant of adjoint of A equal to determinant of A whole to the power of n minus 1. Don't forget, this is a very, very important. Now, another property. That what is A into adjoint of A? Okay. So here A into adjoint of A. Here two adjoints are there. Okay. Adjoint of A equal to. Nice. So I don't write here. Okay. I'll prove this so that you can understand. Now, we know that A into adjoint of A into adjoint of A equal to det A into I. Okay. So this is the parental concept. This is the parental concept to understand the further things. Remaining derivations, you can say simply like derivations. So this implies, now in place of A, you write adjoint of A. Just you write in place of A, you write adjoint of A. So here adjoint of A. In place of A, I am writing adjoint of A. Right side, determinant of adjoint of A into I. Well, so this is nothing but this implies. Okay, so I need that what is adjoint of A. So this you send that side. Okay, so I am writing this. So this implies adjoint of A equal to right side you will get adjoint of A whole inverse. Okay. What is determinant of adjoint of A? This is det A whole square. Assume this is 3 by 3. Assume this is 3 by 3. Now, so here I'm writing a few things that AB equal to I. AB equal to I means you can write directly B equal to A inverse. AB equal to I means B equal to A inverse. That I wrote here. Now, what is adjoint of A whole inverse? You see, adjoint of A whole inverse equal to A by det A into det A whole square. This I got from this only. This adjoint of A send RHS and bring that det A to the left side. So, if whatever we are doing all these things, provided that determinant is not equal to 0. If det A not equal to 0, then only inverse exists. So this is nothing but A into det A. So what is this now? A into det A. This is for 3 by 3 matrix. Well, so now using this concept, now I can write that determinant of adjoint of A. So here I am writing what is that determinant of adjoint of A. This is okay. So I'll write here that determinant, not determinant, adjoint of A n by n matrix is nothing but A into det A power n minus 2 here, provided that det A not equal to 0. Here also, provided det A not equal to 0. Well, so now I can take a determinant for this. So determinant of adjoint of A n by n equal to, okay, this is equal to determinant of det A power n minus 2 into A. Assume this is K. So then you will get K power n. So K power n means det A power n minus 2 whole power n into det A, which gives that det A to the power of, here you see, n square minus 2n plus 1. This is nothing but det A power n minus 1 whole square. It is very, very important. This particular concept is very, very important. So if you take 3 by 3 matrix, determinant of adjoint of A 3 by 3, like this. Then you will get n value is 3, so you will get det A power 4. So in this way, you can increase the number of adjoints. You can increase the number of adjoints. So if I take 3 adjoints, so determinant of adjoint of A. So here I have taken 3 adjoints. Now this is nothing but det A to the power of n minus 1 whole cube. N minus 1 whole cube. So here we got n minus 1 whole square. Here n minus 1 whole cube. So if we take that this is n by n matrix, well, so if we take that adjoint of A 3 by 3 matrix. If we take A 3 by 3 matrix, then this is equal to, okay, det A to the power of n minus 1 whole cube means you will get 8. Well, okay. So in this way, you can take even 4 adjoints also. Once you understand the concept, you can increase the number of adjoints. So adjoint of A. Because they are asking these many adjoints, they are asking in the exam. 1, 2, 3. 3 parentheses from left side, right side also 3 parentheses. This is equal to, you can write det A to the power of n minus 1 whole to the power of 4. Finally, that what is adjoint of A inverse? Adjoint of A inverse. This is same as of adjoint of A whole inverse. Both are same. So instead of writing that answer, I'll prove it in just one line. So we know that we have that A into adjoint of A, okay, equal to det A into I. This implies send this side this and this side, okay. So you will get A by det A equal to that adjoint of A whole inverse, provided that A not equal to 0. Means A is a non-singular matrix. So you can write here simply, this is nothing but A by det. But how we prove this? Simple. So here in place of A, you write A inverse. A inverse into adjoint of A inverse. In place of A, you write A inverse. This is equal to determinant of A inverse into I. So this is nothing but send this A inverse that side. So you will get A adjoint of A inverse equal to A, and det of A inverse is 1 by det. Bracket. Now here since I am writing that determinant of A inverse equal to 1 by det. So these are the very most important, not only in JEE, in coming years, this kind of important concepts will be repeated many number of times. So, and finally, that adjoint of AB, I can write this is adjoint of B into adjoint of A. So, proof is quite simple. You see, AB into, provided A comma B are invertible. A comma B are invertible matrices. Otherwise, this is not possible. So AB into adjoint of AB equal to, this is det AB into I. Well, so now you see left side we have A, you multiply with A inverse. So A inverse into A into B and adjoint of AB equal to A inverse. This is det A into det B. Anyway, A inverse into I is nothing but A inverse. Now this becomes I. So I into B is B. Now multiply with B inverse. Okay. So B inverse into B, adjoint of AB. Okay. Right side, you see B inverse into det B. And this is A inverse into det A. So again, this becomes an identity matrix. So you will get adjoint of AB equal to, this is adjoint of B into adjoint of A. Since the video becomes too lengthy, so following this, I'll explain previous J main in the next video.